Hi, anybody in the building? Welcome back to a session with me, your host, Edu Ada. Are you happy to be back? I'm glad to have you on this again. So today we talk about word problems on fraction. There's certain times when you will not have your questions written in the format you always expect. In fact, there are some questions you will not know they are on fraction. You solve them by using addition, carrying out operations on fraction, except you're able to see through the word problem. You may not have to have them in form of 1 over 3 plus 1 over 2 or 1 upon 5 times 1 upon 6. It should not be in this form. Sorry, permit me to do this. Sorry, let me wipe this. So you may not always have them to be in this form. You may not always have them to be in this form. Sorry, I was having issue to clear up that area. So we have a question like this. We have a question like this. So we have what problem? You translate them into things like this, then you solve. As mathematics students, you should be able to interpret what problems and solve them mathematically. So you have a question, and the question says, the question reads, out of 80 granules in a basket, 16 of them are bad. So now say, what fraction of the original number of granules are good? What fraction of the original granules of the original number of granules are good? Two things are important there. One, you need to first note the number of granules that are good. Then, having gotten that, you will get the fraction of the number that are good. Can we move on? Yes. So we have this. We can write on with this. We have this. Out of 80, bad ones, bad is 16. So good, number of good granules should be 80. Sorry, that should be 80 minus 16. And that should be equal to what? You have 4, borrow 1 here. This becomes 10, becomes 7. 7 minus 1, you have 6. So number of good granules that are good is 64. Now the question now says, what fraction of the original number of granules are good? That means the number of good granules upon the total number of granules. So that should be equal to the fraction should be of this form of good fraction of the original number of granules that are good. So you have to look out for the number of good granules, which is 64, then upon total number of granules, which is 80. Then with this, you break down. You can break down with 2, you can break down with 4, you can equally break down with 8. So 8 here you have 8, 8 here you have 10, 2 here you have 4, 2 here you have 5. So our final answer on that question, that is the fraction of original number of granules will be equal to 4 upon 5. We are done with that. The next question, let's go, is similar, but a way, it's also a word problem, but you need to look at it from a different perspective, a logical perspective. So the farmer has divided, okay, a farmer divided into three sections. A farm is divided into three sections. 1/3 for growing yams, 1/6 for rice, the other section for vegetables. What fraction of the farm was used for vegetables? A close look at the question will make you understand that we were told that this farm is divided into three sections. A section for yam, another for rice, and he said another section for vegetable, but the section for vegetable was not given. Now, this is what you need to do. Note. Let me cite an example here. If you have something like this, let me say I have an orange, and I say this orange is divided among 4 people. One person take half of it, another person take 1/3, another person take 1/4. How do you get for this person? What fraction would the 4th person take? All you have to do, you should know that this orange is a whole, is 1. So you add everything in this, all the fractions that make up this orange will be equal to 1. So with the same idea, we solve this question. So you have the section, the farm is divided, 3 sections, 1/3 plus 1/6 plus another one, a third section which is unknown. So I can write it by saying I have 1/3 plus 1/6, then plus 1/x. Yes. I have 1/3, 1/3 plus 1/6 plus 1/x. I don't know the value of the third fraction, but and the value of the third section, but it's a fraction. I have 1/x, then that should be equal to 1. 1. I can equally say 1/1, which of course you know is 1. So what do we do here now? Since you have this plus this plus this, you have 1/3. You can solve this question going by another approach. Okay, let's get down to this first. You have 1/3, 1/6. So let me repeat this. What do? Look at the denominators. What is the LCM for all the denominators? We know x is not known. So what do? The LCM of 3, 6, and 1 is 6. Multiply through by 6. So you have 6 times 1/3 plus 6 times 1/6 plus 6 times 1/x, and that can be equal to 6 times 1/1. What do we have? 3 here, 1. 3 here is 2. 6 here, 1. 6 here, 1. These x and 6 cannot cut each other, right? 6 times, so we have 2 plus, this is 2 times 1, 2, plus this one will be 1, then plus 6 upon x, and that can be equal to what? can be equal to 6. You can just multiply, you should have multiplied through by 6x, but I don't want to bother you with that. With this, you can easily go. So you have this cleaned up. So here, what do we have? We have 2 plus 1, you have 3. You have 3 plus 6 upon x, that is equal to 6. Isn't it? Yeah, you can collect like terms. How do you collect like terms? There's one that is having a denominator of x, which is our unknown. Others are numbers. So when you collect like terms, you get rid of this 3. How do you get rid of this 3? You have 3. Introduce is a plus 3. Introduce a minus 3 so that you can get rid of it from the left hand side. Get rid of it at this left hand side. Then you have plus 6 upon x. That can be equal to what? 6 minus 3. Isn't it? So what do we have? This and this, they are as good as gone. So 6 upon x can be equal to 3. So since you have 6 upon x equal to 3, this means 3 over 1. Isn't it? Then from here you are looking for x, right? Multiply both sides by x. That's how you can eliminate this x. So multiply this left hand side by x. X will cross out x, you have 6 left. So here you have x times 6 upon x will be equal to x times 3 upon 1. This cancel out this. So what do we have left? You have 6 to be equal to 3x. And this also implies that 3x is equal to 6. Isn't it? So since 3x is equal to 6, you are looking for x, right? And which is the coefficient, 3 is the coefficient of x. So what do we do? You have 3x is equal to 6. Divide both sides by 3. This cancel out this. Then you have 3 here 1, 3 here 2. So x is equal to 2. Don't forget, we add 1 over 3 plus 1 over 6. So it means here we add 1 over 3 plus 1 over 6 plus 1 over x. Our x is now 2. So you have this, clean this, clean this. So you have 2 here. This should give us 1. If you check it out, the LCM, it will give us 1. So that means the fraction of the farm used for vegetable is 1 over 2, which is the half of the whole farm. Thank you very much. I will catch you later. Be good and safe.